Hello viewers, welcome to my video where I'll be covering November 2021 IEB from question 1 to question 7, and then I'll do another video covering question 8 to 12. Without spending much of the time, let's get into it. Now, the strategy that I'm going to be using is the KTE strategy. What does that mean? Know what you're dealing with, think and strategize, and then you execute the plan. Right now, let's solve a part 1. They say use this formula. Now already you know that that is the quadratic formula, and you need to think, what do I use it for? I use it for solve quadratic equations, right? And is there any desired form that I need the quadratic equation to be in before implementing it? I need to have everything on one side. Now, here, do I have everything on one side? No. So you need to put everything on one side. So I'm going to throw this 3 to the other side. And what is the consequence of that? The sign on the 3 becomes a minus. Now we have 3x squared minus 5x minus 3 is equals to 0. Now we have the desired form, because we are going to say a is the coefficient of x squared is 3, b is minus 5, and c is minus 3. And then implementing the formula, we're going to say x is equals to minus b, which is, so we're going to say minus b, which is minus 5, plus or minus square root of b squared, it's minus 5 squared, minus 4 times a, which is 3, times c, which is minus 3, everything over 2a, which is 2 times 3, and then x is equals to what? So let's bring the calculator and let's solve the problem. Now here we are going to say minus 5 plus, so for now let's go with the plus, and then square root of minus 5 squared minus 4 times 3 times minus 3, and then 2 times 3. We get 2.14 to 2 decimal places, so we get 2.14, or we are going to change the sign into a negative. This one we delete and then we change it to a negative, or we get minus 0.47. Now we are done with the first problem. The second question is asking hence. Now whenever you see hence, try to see if you can use the previous result that you have. Solve for x, whereby we have this part greater than 0. It looks similar to what we had in this state. It's just that instead of equal sign we have greater than 0. Now that is okay. And then what do we have? We need to know what we're dealing with. That is a quadratic inequality. Now whenever you have a quadratic inequality, there are many tools of solving, but I am used to the one of sketches. So for the sketch, whereby I check the coefficient, like the structure of the graph, if a is greater than 0, the structure for the quadratic graph, I expect it to be looking like this. When a is less than 0, the structure of the graph should be looking like this. But here our a is 3, right? Our a is 3, and also similarly our a is 3, meaning it passes this test, right? This test. Now the structure of the graph is going to be like this, and then we solve for these points, like for the critical points. And the critical point, we have already solved them. We got it to be minus 0.47, and we got to be 2.14. And what are we saying? We are saying we're interested when the left hand side is greater than 0. It means we're interested in the region when the graph of the region is above the horizontal line, because if it's greater than 0. If it were less than 0, we're interested in the region when it is less than 0. So for above 0, we get it here, and we also get it here, because that's where it is above the horizontal line. Now, everything here is valid, and also everything here is valid. Now, the solution it is, for every x that is less than minus 0.47, or for every x greater than 2.14, it will be valid. Now we go to the next problem. The next problem, we are given two equations. So what is this? This is non-linear simultaneous equations. Now you know what you're dealing with. Now, which two do I need to use to solve this? You are trying to think, right? Now I can use substitution. Looking at the first part, I can notice that here I can make it 2y equals 2. If I throw this to the other side, it becomes a positive. I have 24x. I'll divide by 2. I divide by 2. It means y is 12x. Now, let me label this one. And let us say, okay, y equals to x squared plus 5x. I will label it equation 2. Now, what I'm going to do, I am going to substitute 1 into 2. So what that means, where there is y, I'm going to replace with 12x, because that's what I'm going to do. So 12x is equals to x squared plus 5x. And then now it's a good habit to have everything on one side. So it will be 0 this side, and then this is x squared. And then 5x minus 12x, that will be minus 7x. We're going to factor out x. We are going to be left with x minus 7. And then it means that x is equals to 0 or x is equals to 7, because we are going to say this is equals to 0 or this is equals to 0. Now that is what we get. But then we also need to get the y values. Now the y value, we can get them from the equation 1. So when x is 0, y is 0 as well, because 12 times 0 is 0. When x is 7, it is 12 times 7, which is 84. So y is 84. We are done. Now let's go to the next problem. The next problem, solve for x. Now what do I notice? I notice that this left hand side, this part is protected by a square root sign. So my task is to remove the protection, because we don't want what we want to solve when it's protected. It's kind of hard for us to solve. And for us to remove the protection, usually we prefer it to be standing by itself on a side. So I'm going to throw this to the other side, so that the term that I want to remove protection on, it will be standing by itself. Now I'm going to throw it to the other side. I'm going to be having the square root of x plus 7 is equals to x. When I throw 6 to the other side, it will be minus 6. So it will be 1 minus 6, that will be minus 5. To remove the protection of a square root sign, you have to square both sides. Now that means we are going to have x plus 7 squared is equals to x minus 5 squared. And then here we're going to be left with x plus 7 is equals to, and then if we expand the bracket on the right hand side, you're going to be having x squared minus 10x plus 25, right? And then now we need everything to be on the same side, so I'm going to throw this from the left to the right. Now it means I'm going to have x squared minus 10x minus x, it will be minus 11x. 25 minus 7 is going to be what? So without making mistake, let me also just double check. So 25 minus 7, it should be 18, okay? All right. Now we have plus 18 equals to 0. Now what do we have now? This is a quadratic equation. What two do I need? Either factorization or completing sorry, or using the quadratic formula, right? Now, using the technique that you are familiar with, I've created a video on how to do this. So this is like the coefficient is like a 1 there. So what I do, so I'll put the side note here on the formula sheet. So but this usually to be the scratch work of the strategy that I use. I say you multiply 1 by 18 to get a CS. A C is 18. Now 18 is not a perfect square. Between which perfect square does it lie between, or which perfect square are closest to 18? It is 25 and 16. But then we are going to focus on the perfect square that is on the left hand side, which is m squared. So m squared is 16. It means my m is 4. Now when m is 4, it would mean that my trial zone will be from 1 to 4. And why do I need this trial zone? So that I'll be saying 18 divided by 1 to get a pair, 18 divided by 2 until 18 divided by 4. If I don't get a pair there, it means factorization will not work. And when we're generating those pairs, we also need to check if that pair is going to form minus 11 in any way. So that is what we are going to do. I know it's a bit lengthy, but I'm just demonstrating that. The next ones I will not be, if we encounter a similar problem, I won't be solving them like that. We just jump straight to the solution. So we're going to say 18 divided by the first number from the trial zone. It is 18. Can 1 and 18 form minus 11 by any chance? There is no way. By addition or subtraction, it can never. Now let's try 2. Now 2 and 9 can form minus 11 by saying minus 2 and minus 9. Now, can minus 2 and minus 9 form 18? Because our goal is to form AC. Yes, they can, because minus 2 times minus 9 is 18. So it means that we have got the pair. So the pair that we have got is minus 2 minus 9. That is the correct pair. So this is, it's happening just on your scratch work. And sometimes when you've practiced these exercises, it can happen immediately. We can see the pair that works. So now here is just going to be what? It's going to be x minus 2, x minus 9 equals to 0. It would mean that x is equals to 2 or x is equals to 9. But then the challenge is that we need to check at this point. Because of this square root sign, we expect the right hand side to be at least greater than or equal to 0. If we put 9 here on x, it will be 9 minus 5. 9 minus 5 is 4, which is positive, so it's valid. Now, if we say 2 minus 5 is minus 3, it is not valid. So this one will not be a valid solution. So the only one that we need is x equals to 9. So that is how you solve this problem. Now let's go to the next one. So here they're saying the first 3 terms of a geometric series. So we know we're dealing with a geometric series. Okay, cool. And then we need to think. So that means we need the theory behind this geometric series. Right? Now we are given that 2, 6, and etc. we are adding. And if Sn is that, what is the value of n? Whenever they say calculate the value of n, what they are requesting is that make sure you have an equation that involves n that you need to solve. That is what they're just saying. Now, based on the given information, how can I create that equation? Obviously, we have the left-hand side should be equal to the right-hand side. That is how we are going to set up the equation. So the left-hand side is Sn. But then, do I know a formula for Sn when I'm dealing with a geometric series? You're trying to think. Yes, I know it. It's this one on the formula booklet. Now, I need A. A is the first term. So A, I already have A is 3. It's 2. Now, what about R? Do I have R, which is the common ratio? No, I don't have. So that is the first thing that you need to calculate. So R is 6 divided by 2. So the 6 divided by 2, or we are going to say 18 divided by 6 is going to give you the same answer, which is 3. Both A, we say it is 2 already. Now Sn is going to be what? Is going to be A is 2, R is 3 to the power of n, but n is what we need to solve. which is 3, which is n, right, minus 1, everything divided by r minus 1, which is 3 minus 1, should be equals to, or the right hand side. So the right hand side is 177,146. Now 3 minus 1 in the denominator is 2. So 2 divided by 2, it's 1. So we're just left with 3 to the power of n minus 1 is 177,146. And then 3 to the power of n is equals, if we throw it to the other side, it will be a plus. So it will be 177,147. And then we apply the logarithm both sides to drop the n, because the idea we need n to be on the ground if we cannot use the method of equating the exponents. So we are going to drop down the n, and then this is the logarithm or the ln of 177,147. To get to solve for n, we need to divide by ln 3 both sides. Divided by ln 3. It means that n is equals to what? So let's get our calculator and we get the solution. It means now we are going to say ln 177,147 divided by ln 3, which is 11. So that is our solution. So n is 11. So that's what you need to do there. And then now the question is, using first principles, find f prime. Do I know the formula for finding f prime using the first principles? You go to your answer sheet. It is just this one. Now we are going to say f prime of x is equals to the limit as h approaches 0 of f of x plus h minus f of x over h. Now, do I have everything that I need to implement this formula? Yes, I have f of x, but I don't have f of x plus h. Now, how can I create f of x plus h when I have f of x? Now, to create f of x plus h, I need to make sure that where there is x, I'm replacing with x plus h. That is the change that needs to happen. So where there is x, I'm replacing with x plus h. And then where there is x, I'm replacing with x plus h. And then I'm going to expand this bracket with the method that is faster to you. Just do the method that is quicker to you. So x squared plus 2xh plus h squared. I'm done expanding the first term. And then I distribute, which is minus 5x minus 5h. So we are done on this one. Now let's go on to implement it into the correct. So we are saying f prime of x is equals to the limit as h approaches 0 of f of x plus h. We've already got it. So let's write it down, which is x squared plus 2xh plus h squared minus 5x minus 5h. And then we're going to subtract f of x. So here, remember, we are going to get minus x squared, and then minus it will be plus 5x divided by h. And then this is the limit as h approaches 0 of, so this and this will cancel, this and this will cancel. But if you look carefully, h is common here, h is common here, h is common here. So I'm going to factor it out. I'm left with 2x plus h minus 5. Everything divided by h. Now here, which is the limit as h approaches 0 of, this and this will cancel. So I'm left with 2x plus h minus 5. Now as h approaches 0, this will disappear because it's approaching 0. And you are only left with 2x minus 5. We are done. And then let's go to g prime of x. Now, here they did not give us a restriction of saying using first principles. So you just have to differentiate it the normal way. Now, is there a nicer form that I need gx to be in that makes differentiation easier? It is easier when you are raising x to the power of something, x to the power of something. It is easier to apply your theory nicely. So now let me transform this cubic root into the normal thing. We need to remember your laws of indices. So that is similar to x to the power of 1 over 3. And then plus 6, and then 1 over x is the same thing as x to the power of minus 1. And then now let's get g prime of x. It is just the derivative. Now we will drop 1 over 3, and then we'll subtract a 1. So 1 over 3 minus 1, it will be minus 2 over 3. And then if we drop a minus 1, it will be 6 times minus 1, it will become minus 6. X to the power of minus 1 minus 1, it will become minus 2. Using that knowledge of deriving all these like this expression. Now let's go to C. They are saying that h of x is a tangent to f of x. Find the value of p. Now, I know that I am having a function and also I'm having a tangent. Now, you need to think, is there anything that helps me to connect a tangent and a function? So let's just do a simple sketch, because already we know that there is a minus. So we expect this graph maybe to be something of this form, right? Just a sketch. And then because the gradient is a minus there, it means the gradient of h of x is like decreasing, something like this, just a simple sketch, right? So this is the graph of f of x, and this is the graph of h of x, not the actual one, just a sketch provided with whatever that I'm given. Now, is there any theory that can help me connect f of x and h of x? So from my side, there is nothing, like no theory that I'm aware of that can help me to connect h of x and f of x. Now, let me try to see, can I go a step further? Can I connect f of x and h of x indirectly? Yes, via the derivative. So if I differentiate f prime of x, is there any way I can connect it with h of x? Right? The theory is that I know that when you differentiate f of x and you set it equal to the gradient of h, you find the point that they are connecting or they are touching. So that is the theory. Now, f prime of x is going to be what? Is going to be minus 2x plus 3. So what do I know? I know to connect the derivative to the gradient of h of x. The gradient is the coefficient of x, which is minus 1. Now, I'm going to say minus 2x plus 3 is equals to minus 1. So minus 2x is equals to, if we throw 3 to the other side, it will be minus 3. Now, minus 1 minus 3 is minus 4, divided by minus 2, divided by minus 2. It means that x is going to be 2. So it means the x value, when this graph of f of x and the graph of h of x, they are touching, the x value will be 2. Now let's also find the y value. So the y value is when f, we are plugging in our 2, which is minus 2 squared plus 3, and then substitute 2 plus 4, which is going to be minus, so 2 squared is 4, so minus 4 plus 4 will cancel each other, this and this will cancel each other, and we just left with 6. So it means here there is 2, 6. So the point where the graph of f of x and the tangent are meeting, they are meeting at 2, 6. But then here our goal was to solve for p. Now let's say h of x, at this point we have a y value of 6 when x is 2. So we are going to say 6, here we are replacing with, so okay, maybe another way so that I just show you. I'm saying h of 2 is equals to minus 2 plus p. But then remember, at this point, h of 2 is going to be equal to f of 2. So that is was when they are touching, that we will conclude this. Because we conclude that we are going to say our f of 2 it's 6, so it means we are going to replace where there is h of 2 with f of 2, which is 6, which is what I've done here, and is equals to minus 2 plus p. Now p is equals to, we will throw this to the other side, it will be 6 plus 2, which is 8. You are done solving that one. And then let's get to this one. Here, for this kind of graphs, you need to know that here, whenever you have a graph of the form, let's say f of x is equals to a to the power of x plus b, the structure of the graph, it will be determined whether a is greater than 1 or a is less than 1. You need to remember that. So since our a is 3, right, it is greater than 1, we expect our graph to be something like whatever that you are seeing right now, right? But now the issue, there will be some translation that will be happening, so I'll touch on this concept later. For now, let's see the problem, because this one, it has a bit of translation here. I just wanted to touch the graph of like okay, so let me just go down and then let's try and see how we build the concept before I create a bit of confusion. Now write down the domain of f. So what does that mean? Where is the value of x defined? Like, is there any point of x that can invalidate this graph? You're asking yourself. If I check, if I say x equals to 0 is valid, x equals to 1, or x to the very big number is still valid, x to the very smaller number is still valid. So there is no x that can make this graph invalid. So when you cannot find an x value that can make it invalid, it means all x element of the real numbers will work. It will be our domain. If there was an x that are going to invalidate or to make our f of x undefined, we're going to take only the values where x is defined, or it's not going to make the function something bad or something that will not exist. And then now write down the range of f. So the range of f, we are looking at the y. Where now, what do you notice? You notice that here in this case y is equals to minus 2. You are not allowed, this graph is approaching minus 2, but it's not allowed to touch it, meaning it is valid everything above this minus 2. So that is what we can conclude. In everything above it, it's valid. So when you are saying everything above it is valid, what does that mean? It means that for every y greater than minus 2, or in set notation, for y element of minus 2 to infinity. Remember, you put a round bracket when you are not including, but you put a square bracket when you are including minus 2. So since we are not allowed to touch the asymptote, there's a bracket. So either this or that is fine. Now write down the equation of the reflection of f in the x-axis. So what we are going to do, we're going to say let h of x be our new graph such that it is a reflection of f in the x-axis. So what that means is that h of x is going to be what? When you are reflecting in the x-axis, your minus should be outside. So you are going to say minus f of x. If it were reflected in the y-axis, your minus was going to be inside the bracket. So that's what you need to remember. Now, here we are having minus. So f of x, we just need to put minus in front of 3x and also minus. So when you do that, it will be minus 3 to the power of x plus 2. So that is what is going to happen when we put a minus. So it's minus 3 to the power of x minus 2 but that was our original one, this one. And then we are going to put a minus to distribute the minus. So we are going to be having minus 3 to the power of x plus 2. So that's what we have here under this problem. And then the second question is asking, determine the values of x for which f of x is greater than or equal to 0. So we said our f of x is 3 to the power of x minus 2 is greater than or equal to 0. So for which values of x will f of x be greater than or equal to 0? Now at this point, what I'm going to do, I'm going to throw this minus 1 to the other side. And then we now have 3 to the power of x is greater than or equal to 2. Now at this point, I need to drop down the x. So to drop down the x, I need to apply ln. Now, or the logarithm. So it will become x ln 3 is greater than or equal to ln 2. So the reason why I threw the minus 2 to the other side, usually when you want to drop down the x, you need to apply a logarithm. When you're applying a logarithm, you just need to make sure that that thing that you want to apply a logarithm, it is standing by itself. So that's why I had to do that. Now at this point, I'm going to divide by ln 3. I divide by ln 3. So let's go to the problem. We are going to say ln, oh sorry, I will correct it just now. It's ln 2 divided by ln 3, which is 0.63, which is equals to, was it 0 or minus, or what was it? Let me just try to check. Can't remember. Was it a minus or a positive? Let me just say, sorry for the, so we said ln 2 divided by ln 3. Oh, it was a plus. So we had 0.63, or usually they said to 1 decimal place unless otherwise stated. So we could also have said for x greater than or equal to 0.6. Here I was saying I'm gonna correct this one. Oh, okay, no, it's okay, because I said this and this will cancel. Yeah, sharp. And then now let's go to B part 1. So B part 1 is saying on the same axis, sketch g of x, where g of x is minus 2 to the power of x plus 4. Now, you need to understand the theory. So for now, let us just do the random theory. Let's say this says sketch g of x of 2 to the power of x. Now, when you are sketching g to the power of 2 of x, your graph will expect it to be, because remember we said there are two cases. When a is greater than 1, we expect the graph to be looking like this, right? And when a is less than 1, like for a graph like this, you need to know that the graph will be looking like this. Then this is like coordinate 0, 1. This is coordinate 0, 1. So that is the general structure. This is your a. So this is the position of a, like the general structure of gx. If it is a to the power of x, we expect our general form of the structure to be like this if a is greater than 1, and to be like this when a is less than 1. Now, looking at the graph, we know that our general structure of the graph, it will be this one since it's greater than 1. But now the issue there, the issue, there is a minus before that. So if there's a minus before this one, it is a reflection in the y-axis. So that is another thing that you need to keep in mind, right? So since it's a reflection in the y-axis, so now I'm going to erase and justify a bit of it. So if it's a reflection in the y-axis, What does that mean? So let me just, both already I gave you the cases that to be on the lookout for. Now, because it was like that, it means it will be like this. If it is reflected in the x-axis, it's like there's a mirror. So the general form of the structure that I want to get for the graph, it is supposed to be like this, going downwards. The asymptote here, because it was 0, it can never touch 0, because we were just using what? We're using minus 2 to the power of x. But then if we are translating plus 4, it means our asymptote now will be on 4, but the structure of the graph will be something like this. So that is what you need to remember. So with all that theory that you need to keep up, unfortunately I cannot put all the theories that we may need, but at least we now have an idea of what's going to happen. So we know that the asymptote is going to be, like for example here it was minus 2, the asymptote was at minus 2. With our problem we have plus 4, it means our asymptote will be at plus 4. That is the same logic. So we have our asymptote at plus 4. And then the structure of the graph, we said it will be going down now. The structure of the graph, it will be like this, if you checked what I said. Now that is it, we are done for that one. Now here it is, they are saying now, determine the equation of the resulting graph of G. Okay, determine the resulting graph if G is shifted 3 units vertically. So what that means, we had G of x, which was minus 2 to the power of x plus 4. If we are shifting it vertically, we are adding 3. They're saying up. If it was down, we're going to say minus 3. So that means we are having minus 2 to the power of x, 4 plus 3, that is 7. So that is the equation, but they just say determine the equation. So we are done. Now we go to the next one. They're saying show on your graph where you would read off the solution of 3x plus 2x equals to 6. Now here I can see that I have a minus 2 to the power of x. Cool. Now let me check the original graph that I had. So the original graph that I had, it had 3 to the power of x minus 2. So let me just clean it up so that you can see it clearly. It had 3 to the power of x minus 2. So that was g of x, that was f of x. Now I need to find a connection to link f of x and g of x. That's what it means. I need to find the connection that exists. But then the issue, there is a 6 there. Now which one? We try to check, is there any 6? I only see 4 there. And then on the other one, do I see 6? I see 2. But then I have a feeling that 4 plus 2 is gonna give me 6. It means there has to be some relationship that exists between f of x and g of x. So what I'm gonna do, first of all, I'm gonna try to say f of x equals to g of x. And I try to see if it will lead me to this form. If not, I'll try maybe f of x equals to minus g of x, like to try as many ways as I can to see what is going to happen. And the idea, I need to show on the graph where what's going to happen. So I know that f of x is what? F of x, I know f of x is 3 to the power of x minus 2. So I have 3 to the power of x minus 2, which is equals to g of x. G of x is minus 2 to the power of x plus 4, which is minus 2 to the power of x plus 4. And I can throw this to this side. I will get 3 to the power of x plus 2 to the power of x. And then I will throw this to this side. It will become a plus, so it will be 4 plus 2. It will be 6. Now, What that means, we are just solving f of x equal to g of x. So to show on the graph, we just need to show that, so for point 3, it will be, this is the point A. So where like g of x and f of x are intersecting. So that is the graph that we've shown. So we are done with this part. And then let's go to question 4. So for question 4, what's happening? We are saying that we have 5 over x minus p plus q, and we also have g of x equals to the log of whatsoever there. Okay, cool. Now, what's next? They are saying if h of x is equals to x plus t is an axis of symmetry of f of x, determine the value of t. Now, you know there are many ways of creating the equation of a line. So one of it is this one. Now, you can even go via that route. So why can we go via that route? Because they are saying h of x is an axis of symmetry. So when it's an axis of symmetry, they are telling us that its gradient, so the coefficient of x is the gradient. So the gradient, meaning that m is going to be 1. That's what it means. Now, let's see how would we have constructed this h of x. Was it is an equation. We could have used also this one. But then we know that the gradient of it is 1. And then now, we need a point where this axis of symmetry is going to pass. So the axis of symmetry is going to pass this point that we call 2, 1. It's going to pass those at the intersection of the vertical or that point. Because why? Because let's go and let me just show you. Because we are saying x equals to 2 is an asymptote, and y equals to 1 passes through C and is an asymptote to f of x as well. So the intersection of that, which is 2, 1, which is the coordinates 2, 1, will be a point where the axis of symmetry is gonna pass. So we have our point, which is x1, and this is y1. So that is another way of thinking about it. So the equation of the line, we are saying it's y minus, so this is, I'm saying it's x1, this is y1. So I'm going to say y minus y1 it's 1, is equals to m, it's 1, and then I open the bracket, and then I say x minus x1 is what? x1 is 2, and then here I have y is equals to 1 times x is just 1x, so just x, and then 1 times minus 2 is just minus 2, and then if we throw this to the other side, it will be plus 1. Now we have y is equals to x, so minus 2 plus 1, it is minus 1. Now, what we have created, it is an equation of a line, and that line is supposed to be h of x. So h of x is supposed to be x minus 1. Now, if you look, we need to solve for t. So that means we can deduce that t is supposed to be minus 1. You are done. So that is how I would have solved this problem. Now, let's go to the next one. The next one is B. We need the coordinate of C. Now, let's go and check. We have C here. C is what information do we know about C? We know that y equals to 1 passes through C. Okay, so that's another information that we know about C. And what else? We can see that also it is sitting on G. Right? Now, remember, y is equals to g of x as well. We can say that. Or y we can also is equals to f of x. Now, what that means is that to find the intersection point, we are going to say, and we know that y is equals to 1 at the intersection point. So what we are saying, we want to solve g of x equals to 1. So that is to get the coordinates of C. We are solving g of x equals to 1. Now, with g of x equals to 1, we are saying log x3 is equals to, so we are saying log x3 is equals to 1. So that means that the x value is going to be 3 to the power of 1. Remember a lot of logarithms, so which is just 3. So we know that your x value will be 3. And your coordinate of c, it will be 3, 1, because we said our y value will be 1 at that point. Because our value of y will be 1 at that point. So the coordinate of c is going to be 3, 1. And then let's go to the next one. Find the length of AB. Now let's go and check. This is the distance formula. And what do we use it? We use to calculate the length. So you will check if you will need it or not. Now, here we need the length of AB. So what that means, I need to find the coordinates of A and I need to find the coordinates of B. If I can find the coordinates of A and the coordinates of B, that is when I will know the distance of or the length of AB. That is the only way of finding the length of AB. You are trying to think. Now, how am I going to get the coordinates of A? The coordinates of A, they are corresponding to what? They are corresponding to the graph of F. And the coordinate of B, they are corresponding to the graph of G. But then for the coordinate of B, we see that we are touching the x-axis. So when you are touching the x-axis, here our y is equals to 0 when you are touching the x-axis, right? When you are touching the x-axis, y is 0. Now, to solve for A, it's when y equals to 0 for the graph of f of x. To solve for coordinate of B, it's when g of x is equals to 0. So that's how we're going to proceed from that. So f of x is equals to 0. And now here we're given the structure of this graph. Now f of x we can deduce is what? It's 5 over, remember our p, it's supposed to, both remember our asymptote is at 2. Now, so it means it will be x minus 2, right? And then plus, and then our let me just check again to verify. But okay, so for x, yeah, for x is 2, yeah, correct. Our y is 1, yeah, so which is 1. So for the asymptote, you take the asymptote of y is the one that you say plus, and for the asymptote of the x is the one that you need to make sure that you put in the denominator. Why? Because if you say x minus 2, if you are going to say x minus 2 equals to 0 in the denominator, we will get our solution as x equals to 2 as our asymptote. So that is why we can deduce that our f of x is supposed to be this. Now let's go down and put everything. So we are saying f of x is, it's 5 over x minus 2 plus 1. It's 5 over x minus 2 plus 1. And we know that g of x, we said it's log of x 3. Now let us solve for f of x equals to 0. So for f of x equals to 0, it means we have 5 over x minus 2 plus 1 equals to 0. Now it means that we are going to throw this to the other side. So we have 5 over x minus 2 is equals to minus 1. And then minus 1 is like over 1, right? It's the same thing. Now we can cross multiply. So 5 times 1 is just 5. But then let's start with the left, with this cross multiplication of this side. Minus 1 times x is minus x. Minus 1 times 2 is plus 2. Which is equals to 5 times 1 is just 5. And then we can say minus x is equals to, if we throw this to the other side, it will be 5 minus 2. So 5 minus 2 is 3. And then if we divide by a minus, we get that x is equals to minus 3. Now for the coordinates, we get that the coordinates of f corresponding to f, it's the a. So for the a is going to be 3 comma 0. We have minus 3 comma 0. Now let's get the coordinates. So this were the coordinates of a, and then let's get the coordinates of b. We are just saying g of x is equals to 0. It means log of x3 is equals to 0. So x is equals to 3 to the power of 0. If you know your logs, your rules. So it means that my x is going to be 1. So the b coordinate is going to be 1 comma 0. This is what we can deduce. So our b coordinate will be 1 comma 0. But then since they are sitting on the x-axis, it means that the y value will not even affect, right? Because it is already 0. So to find the distance from a to b, you can just find the horizontal distance or the difference between the x values. That's how we can find the distance. Or we can implement this formula. You still get the same solution. So it's just say this case is the horizontal distance. So the length of AB is equals to 1 minus 3, because we want to find the difference between those. So 1 minus is 1 plus 3. That will be 4 units. So that is the distance. Now, write down the length of the g inverse of x in the form y equals to something. Now, we know that g of x is equal to the log of 3x. So our goal is to make x subject of formula. So this one is the same thing, right, as saying y is equal to the log of 3x. Now, if we make x subject of the formula, we are saying that x is 3 to the power of y. That is the first thing, change of subject. Now, after I've made the change of subject, you now have the right to say g of inverse of x is equals to 3 to the power. Where there is x now, where there is y, you are replacing with x. We have done the process. But then they said leave it in the form y equals to something. So the solution, you can say y is equals to 3 to the power of x. Then you are done. So that's what you just needed to do. Now we go to another problem, which is for what values of x will f of x multiplied by g of x be less than 0? Now, this is a problem whereby not everything is gonna be as a result of algebraic manipulation. Sometimes you may need to use your ability to reason logically, and you also need to implement, to use the graph that is given to you. Now, because going via the algebra, you are going to die, because there is f of x. F of x is horrible. If you look, f of x is horrible. And then if you times it with g of x, we will get log on the other side. It becomes very horrible. So if you want to do it the algebraic manipulation way, you are going to crash. Now, the two that we will need here now, we need the logic and our graphs. We need our logic and our graph. Now, let's go. Now, let's think about it for a second. When is g of x defined? Note that our g of x should be defined for all the x values greater than 0. That is the first thing we need to take note of. The g of x is valid for not x is greater than 0 for g of x, right? That's what we need. Okay, or maybe the right way I can put it, I can say, right, I can say for g of x, the domain of g is all the x values greater than 0. Why are we saying that? Because remember, g of x, it's a log graph. Whenever you put a log of a negative number, it will not exist. So what that means is that the domain of G is for x greater than 0, but then let's look at the domain of F. The domain of F, we are looking at the asymptote, which is at 2. So we are saying x less than 2 and x or x greater than 2. That is the domain of what? The domain of F. Now, here we already said that for the domain of G, we want the domain of G to be x greater than 0 only, right? So that means the domain of f of x and g of x should be for x values greater than 0 and for x values what? Now let's go and check. Because we said x can be less than 2 or x can be greater than 2. Now here we can say that we can see that x is less than 2. Now we can consider the domain for that G graph. It is coming from x greater than 0 until 2. So that is the domain we can consider. We can say, so for x less than 2, that is another possibility, right? Or what? So now, because now we are trying to figure out where this thing is gonna be valid. Because for the product of f of x and g of x, we are saying we require this x to be greater than 0. We see that, but then also we can require the x to be less than 2. That's another thing. And then now, I think maybe the other case I can leave it because already we have found the point that makes sense. Because remember, if you look nicely here, we were saying for x less than 2, and then also we have x greater than 0, meaning that this region we need to take a look at it. So from 0 to 2, it is this point, this region that we need to take a look at. Now, if we look at that region, let's try to check what do we say. Here we said this is 1. That's another thing that I need to take note. We said our x is 1 here, meaning that I can even split it further into this region, x between 0 to 1 and x between 1 to 2. That is what I can end up even doing. Because the region that we are considering, we can consider from 0 to 2. That's what we are checking. Now, what happens between x between 0 and 1? What happens between x between 0 and 1? We see that for x between 0 and 1, so you see that for x between 0 and 1, we can get that f of x is less than 0, and also g of x is less than 0. All right. Now, if we say f of x times g of x, these ones are negative number. A negative number times a negative number will lead to a positive number, meaning that this region will not hold. Now, let's look at the region 1 to 2. Now, if you look for the region 1 to 2, what do you notice? You will notice that, so remember, this f of x is still gonna go down, down, down. Here I was just labeling. I'm not saying it's an asymptote. Maybe you might get confused. The asymptote is at 2. It can continue to go down and down and down, right? Still, the graph of f of x will be less than what? Will be below the x-axis. So it will still be below. So for f of x will be less than 0 for that region. So f of x will be less than 0 from the interval 1 to 2. And then what else can we note? So from the interval from 1 to 2, we notice that f of x will still be below, right? And then for g of x, it will be above now. It will be above. Now let's go and check. We are saying that g of x will be above 0. Now, a product of a negative number and a positive number will lead to a negative number. So that means that it makes sense to say f of x multiplied by g of x will be less than 0. So this holds logically. This will mark the test. So for which this will be defined, for the values of x between 1 and 2, or another one may want to consider it as 1 comma 2. So this is an example of a question whereby not everything is gonna result as a like algebra. Sometimes you may need to reason logically, and you look at your graphs, you look at the domain, you try to find ways to put things together. So that is what was supposed to be done there. Now we go to question 5. So question 5, it is saying refer the pattern below 4, 9, 18, 31, and etc. Now you ask yourself, which pattern is this? Now we need to find out. 9 minus 4 is what? It's 5. 18 minus 9 is 9. Already there's a change here. We don't have a constant term. Like if it were supposed to be an arithmetic series, we're going to have 5, 5, 5 throughout, or 9, 9, 9 throughout. So it means this pattern can never be an arithmetic series. All right, we have marked this can never be an arithmetic series. Can it be a geometric series? That is another check. So the geometric series, we have to check 9 divided by 4 should be the same thing as 18 divided by 9. 9 divided by 4, you get it like what? This one will lead to 1 and 1 over 4, right? This one will lead to 2. These are not the same. So it means it's also not a geometric series as well. So what is it? The only option that you'll be left with, this could possibly be a quadratic series, right? Now let's check if it can meet that criteria. Now we need a tree that we need to draw. So we have 4, 9, 18, 31, and etc. So for now, let's just take 4, because 4 are enough to draw our tree. Now we are going to do the process, which is 9 minus, I don't know what's happening now. Oh, sorry, okay. What's happening to the mark? I don't know what's happening, it's freezing. Okay, maybe let me write down. I don't know why when I'm writing at the top there it's not making sure. Okay, maybe let me write on the scratch, maybe it will be better, because when I'm trying to write there it's shifting differently. So here I'm saying we have 4, we have 9, we have 18, we have 31. We are going to say 9 minus 4 is 5. 18 minus 9 is what? It's 9. And then 31 minus 18, you get it's what? Okay, let me just bring the calculator so that we don't make a mistake. So 31 minus 18 is 13. Now let's go to the last level. 9 minus 5 is 4. And then 13 minus 9 is also 4. So since we have a constant, right, a constant term on the last row, right, we will note that this is a quadratic pattern. Now to solve for Tn, what is it that we need? So to solve for Tn, it means that we need to make sure that we are saying we are saying that Tn is equals to an squared plus bn plus c. That is the general structure of this one, right? Now, since it's the general structure of this one, it means we need to solve for, our goal is to solve for A, B, and C. Now, how am I going to solve for A, B, and C? It means I need to generate 3 equations. That's what it means. Now, let me generate those 3 equations. And the optimum way of generating those equations is via this route. That is the optimum way. Not what I'm saying is the only way, but it's the best way of doing that. Because this one is term number 1. This one is term number 2 minus term number 1. And then this one, let's say for example, the second level, I'm calling it the difference, right? So for this one, it will be difference number 2 minus difference number 1. Let's say I'm calling it difference. Now, what that means is that for term number 1, we are saying where there is n, replace with a 1. So what you get a plus b plus c to be equals to 4, which is the first term, which is my equation 1. I don't know why it's my slide is acting up now. I don't know. It's equation 1. Hi, what's happening now? God. Okay, let me just erase. Because I'm struggling to label it 1. I'll just find out why this is the case. Okay, and then let's check the other one. The term 2 minus term 1 should be 5. That's what we want to extract. When you get, like, you should know that term 2 minus term 1, if you find their difference, you are guaranteed to be having 3a please let me just pause the video and then let me try to fix it. Yeah, we are back now. I've fixed the problem. So the challenge that I was having, I needed to split the screen again. I don't know why it was acting up at the bottom. Now here I was saying for the second equation, we need to set it equals to 5, right? So since we want to set it equals to 5, we are saying term 2 minus term 1. If you are to do term 1, like if you say t equals to 2, you substitute your things there and then you subtract the t1. You are going to be having 3a plus b should be equals to 5. You are guaranteed that it should be equals to 5. That will become your second equation, right? And then for your last one, you are always guaranteed to have 2a is equals to, like this difference of d2 and d1, you are guaranteed that it is going to be 2a throughout. So this level is going to be 2a throughout. Is the theory that you should remember. This last level should always be 2a. So that 2a should be equals to 4. That is our third equation. And why was it the best way of creating these equations? Because we can solve them backwards. That was the optimum way of generating them. So from the last one, we are going to say a is equals to 4 divided by 2. That is just going to be 2. And then for b, we are going to say b is equals to 5 minus 3a, which is 5 minus 3 times 2, which is 5 minus 6b is going to be minus 1. That is what you can deduce. And then c is equals to, we are going to say 4 minus b minus a. So which is 4 minus, so b is minus 1. And then minus a, which is 2, which is 4 plus 1 minus 2. So 4 plus 1 is 5. Also 4 plus 1 is 5. 5 minus 2 is 3. Now that means that our Tn, so it means that our Tn is going to be, where there is a, I'm going to replace with 2, is 2n squared. Where there's b, I'm going to replace with minus, so minus n plus 3. So that will be the equation that we have determined for Tn. So that is the quadratic pattern. Now, determine the number of terms in the series. Now, here they want you to determine the number of terms in the series. What does that mean? It means solve for n, which is the number of terms. And how do you solve for n? You need an equation that involves n. And it can be created by saying we need until the last term, which means we are going to say Tn should be equals to 949. That is what we need. Now here we are going to bring our Tn, because we said our Tn is Tn squared minus n plus 3. But before you do that, maybe you may need to verify if we have defined it correctly. Let's say when n is 1, 1 squared is 1, so 2 times 1 is 2, and then minus 1 plus 3. So 3 plus 2 is 5, 5 minus 1 is 4. So the first term holds. So it means you got to this correct equation correctly, but you may need just to double check a little bit. Now, what we are going to do, we are going to say 2n squared minus n, and then if we throw this to this side, we are going to say 3 minus 947 minus 949, you get what? You get minus 946 equals to 0. That is what you can get there, right? And then now what's left, we need to apply the quadratic formula, because factorization may take us a bit of time. So n is equals to minus b, which is minus 1, because remember we have solved for our a. Okay, now this is our new equation. So a is 2, b is minus 1, and c is 946. So c is minus 946, sorry, minus 946. So let me just write it neatly. C is minus 946 is minus 946. Now let's put it into the quadratic formula. So for the quadratic formula, we say minus b, which is minus 1 plus or minus square root of b squared, it's minus 1 squared, minus 4a, it's what is 2, c is minus 946, everything over 2a, which is 2 times 2. And then let's put it in the calculator and let's see what we get. So we are saying minus 1 and then plus. So here we need to use a plus for the first case, and then which is minus 1 squared minus 4 times 2 times minus 946 divided by 2 times 2 to get the first one. So for the first one that we got that our n is equals to 22, right? Or our n is equals to what? So where there is a plus, we are replacing with a minus. Or it's minus 43 over 2. So that is what we can get. But then the issue now, the number of terms can never be negative. So this one will not hold. So the only one that works is that we should have 22 terms. That's what it means. And then the next one is represent this in a sigma notation. So the sigma notation, it is starting from n equals to the first term until to the last term of the series, which is the term number 22, and we define the Tn. So the Tn, it was 2n squared, it was 2n squared minus n plus 3. So that is how you would express it in sigma notation. Now we go to number 6. So for number 6, they are saying the details of investment opportunity with a company called Phantom Investments are given below. Monthly payments of 5,000 need to be made at the end of each month, and the interest rate is offered 15% compounded monthly. Please remember, compounded monthly. So whenever it's compounded monthly, you need to remember that your I will not be coming the way you see it. It will be manipulated there. Your new I, we need to create our new I, which if it's compounded monthly or quarterly or whatsoever, because it's not being compounded per year. Now you decide to invest with Phantom in terms of in terms of the terms above, right? What will the value of the investment be at the end of 3 years, right? So the idea is this is time 0, this is time 3, and you are making on a monthly basis, right? And the monthly amount that you are going to pay in this case is x equals to 5,000, and we want to see what will be the value of your investment at the end of 3 years. So you want your value of your investment at the end, which means you need your final value, which means you need your f. So we are saying f is equals to x is the amount you are paying per month, which is 5,000, and then times, we open a square bracket, we say 1 plus, then I said I, you need to be very careful because I now is we are compounding monthly. So you are going to say 0.15 divided by 12. When you divide by 12, you are going to raise by 12 as well. And then times n. N is the number of years. So for the number of years is 3. So you put a 3 there. Now, if it was per annum, it was supposed to divide by 1, you multiply by 1. So it was going to just be, your I was going to be the normal I that you use, and your N was going to be the normal N that you use. So that's what's going to happen there. And then minus 1, everything divided by your new I. So this whole thing, it's your new I, which is 0.15 divided by 12, because we are compounding monthly. So what is the value of the investment? So let's bring our calculator and let's get to see what will be our value of investment. So the value of investment is 5,000 times, we open a bracket, and then here we're going to say 1 plus 0.15 divided by 12, close the bracket, raise to the power, 12 times 3 is 36, and then minus 1, and then we divide by 0.15 divided by 12. So which is 225. Oh, sorry. What's happening with this one? Okay. Sorry for the disturbance. 225, 577 point. So since this is in monetary terms, we can round to 2 decimal places, which is 53. So that will be our solution to this problem. And then let's go to the next one. What are the minimum number of months required for your investment to reach a value greater than 2.5 million? What are the minimum number of months required for your investment to reach a value greater than that stated amount? So what they are saying is that when is the final amount of your investment? Okay. what is the value of n in months such that the value of your investment is greater than 2.5 million. That's what they are saying. So they are saying, what is the number of months such that the value of your final investment is greater than 2.5 million? That's what the question is asking. Now, meaning that in terms of us knowing that we are ending at 3 years, we both remember that if we say 12 times 3, you are getting 36. So over 3 years, you have 36 months. Now the question is asking in months. So meaning that instead of saying 12 times n, we are going to leave it as like n as one term because we want your answer in months. So what we are going to do, we are saying 5,000 times 1 plus 0.15 divided by 12 raised to the power of, instead of saying 12n, we're just leaving it as n because they say they want the answer in months. If it were in years, you're going to say 12n. So we can just leave one variable there, which is n, and then we subtract a 1, we divide by 0.15 over 12. This whole equation should be greater than 2.5. That's what it means. Now, let's try to figure out what's going to happen. So let's simplify this 5,000 divided by this so that we see what we get, and then we see how we can proceed from that. Now we are saying 5,000 divided by 0.15 divided by 12 is 400. It means now we are going to be having 400. So maybe let me write because of space. I think I did not write. Let me. Is there another space? Oh yeah, there's still another space. Okay, let me. So it means this one is the same thing as 400,000, and then 1 plus 0.15 over 2, over 12. Let me just get the answer for that so that it will be much easier for us. So let me bring the calculator. So which is 1 plus 0.15 divided by 12 is 1.0125 to the power of n minus 1 should be greater than 2.5, right? And then we are going to divide both sides by 400,000. We divide both sides by 400,000, meaning on the right hand side you'll be left with 25 over 4, and then 1.0125 to the power of n should be greater than, if we throw 1 to the other side, it will be plus 1. So 25 over 4 plus 1, it is like adding 4 over 4. So adding 4 over 4, yeah, it's like 25 plus 4, which is 29 over 4. So if I throw the 1 to the other side and I add it to 25 over 4, you should get 29 over 4. And then to solve for n, I have to apply the logarithm both sides. So which is ln, so it's n ln 1.0125 should be greater than ln 29 over 4. And then to solve for n, we should have something greater than ln 29 over 4 divided by ln 1.0125. And then let's get what we get from the calculator. So we have ln 29 over 4 divided by ln 1.0125, which is 159.46. So it should be greater than 159.47, right? But then the question is asking about the minimum number of months. So since we are requiring for the minimum number of months, we want it in full. So from there we can conclude that n is supposed to be 160. We can round it up. Because if you round it down and you put it in your equation, it will never be greater than 2.5 million. But if you round it up, then it will be greater than that, then which is 160. Now let's go to the last question of this series of the video. So we are saying that you approach a bank for a home loan to the value of 850. This needs to be paid off monthly over 20 years. Okay, this loan should be paid over 20 years. What are the minimum monthly payments required to pay off the loan over the 20-year period? Now, here this loan is being given to you at the start. So this is a present value moment. So the amount that you are given currently is 850. So you just have to say 850,000 is equals to X is the amount that you need to pay per month. So it's just X. And then we have 1 minus 1 plus. Your I, we need to check. It is 9% compounded monthly. So it means it will be 0.09 divided by 12. When you divide by 12, what are you going to do? You're also going to raise by 12. And then remember, there is a minus. So there is a minus there. So minus 12 times n is the number of years, which is 20. And then we divide by your I. Remember, your I is 0.09 over 12 when we are compounding like that. And then we need to get our value. So let me just... So here we're going to say 1 minus 1 plus 0.09 divided by 12. We raise to the power of minus 12 times 20 divided by 0.09 divided by 12. And then maybe let's just store it as A. So here we are saying that our X is going to be, because we can skip that other step, because then we can just say 850,000. I think there's an extra zero here. Divided by, so you will get that the answer that we get here, it's 7647.67. So we are done with this part. Now let's go to the last part, which is B. If the monthly payment is changed to 9,000. So it means here what's happening, you're paying on a monthly basis your 7,000, right? You're paying your 7,000. And the question is asking about, like, what will be the balance outstanding at the end of 12 years? So what will be the outstanding balance at the end of 12 years? Right? After 12 years, how many monthly payments would you have made? Which is 12 times 12, which is like 144 monthly payments that you'd have made. So there are two ways. Either you can work in the future or you can work backwards. But the challenge that we have is that there is a change in the monthly installment. So since there is a change in the monthly installment, you cannot work backwards. It's kind of difficult to work backwards. So the approach that you will need to do is you need to move forward. You need to move forward. So when you are moving forward, you are going to say your 850 loan that you are given, it's going to increase. So we are going to say 1 plus So we said 0.09 divided by 12 is going to increase to, like, after 12 years, the loan would have increased in value of what? 12 times 12, was it's happening over what? Or over 144 months. So after 144 months, that is how much it would have increased to. And then we subtract how much we would have paid. So we are saying we are fixing it at 9,000. So that is how much you are paying. So in the future, how much would you be having at time 12? So we are taking this 850 to the future at time 12. And then how much would this 9,000 installment worth in 12 years time? Because that's how much we are paying. Now we are going to say 9,000. We are using this future formula. And then we are going to say 1 plus, so your I, it's 0.09 divided by 12. When you divide by 12, you have to raise by 12. And then this is the duration. It's like until the 12 years. So 12 times 12 is 144. So we're leaving it as 144. And then minus 1 divided by your I. Remember your I, in this case, it's 0.09 divided by 12. So what we just need to do, we need to get our answer here. So let's bring the calculator, and as we wrap up, it means that we have 850,000 times 1 plus 0.09 divided by 12 raised to the power of 144. Then maybe let us store as A. And then the last one is 9,000 times, okay, we'll open the bracket, 1 plus 0.09 divided by 12. And then we close the bracket, we raise it to the power of 144. We subtract 1. We divide by 0.09 divided by 12. We get our answer. We store it as B. So recall A minus recall B, what will be our solution? So we get 173,507.13 will be the balance at the end of 12 years. Thank you so much for listening. Stay tuned for the next video that I'm going to create.